Our first video will be a review of 8-2 trigonometric ratios. Okay, we've been out of school for about 2 weeks, so I think it would help to begin by reviewing the lesson in its entirety. Okay. So we started with the trigonometric ratios, the trigonometric functions: sine, cosine, and tangent. Okay, where sine is the ratio of an angle labeled x of the opposite leg divided by the hypotenuse. Okay, so what do we mean by opposite leg? Well, if you remember, let's draw a right triangle A, B, C. Okay. Now the three sides will also be labeled A, B, C, with lowercase a being one of the legs, lowercase b representing the other leg, and lowercase c for the hypotenuse. So now let's turn back to sine. So again, the sine of the angle x is equal to the ratio of the opposite leg divided by the hypotenuse. So if we look at angle A, let's mark that. Right here, which of the two legs, A or B, is across from it is on the opposite side. Okay, picture yourself as point A. You're standing in a room, so which of the three walls is opposite from where you're standing? Well, that would be lowercase a. Now remember, C is the hypotenuse because it is across from the 90-degree angle. So the hypotenuse is really the one that you should label first. That's where you should begin. Because it doesn't matter where you are standing, the hypotenuse is always going to be the hypotenuse. And again, opposite, and that depends on where you're standing. So in the case of A, the opposite is lowercase a. And therefore, the sine of angle A is the ratio of leg A, the opposite leg, divided by the hypotenuse C. Okay, so again, that's your sine of A. Now cosine, abbreviated COS, so the cosine of an angle is the adjacent leg. Okay, let's make a little room here. Oh, well, that's not working. Again, cosine, abbreviated cos, of an angle represented by the variable x here is the ratio of the adjacent leg divided by the hypotenuse. So now by process of elimination, since we've already established with respect to angle A, side A is the opposite, then by process of elimination, B should be the adjacent leg. So you notice the color coding. Angle A is represented with the blue. And later on we will represent angle B with green. Remember, another way to think about adjacent is next to. Okay, this side, lowercase b, is next to angle A. So therefore, cosine of angle A is B divided by C, the adjacent leg divided by the hypotenuse. Then finally, tangent of A would then be lowercase a divided by lowercase b. Since tangent, abbreviated TAN of angle X is the length of the opposite leg divided by the adjacent leg. Did a little backwards there, but still works out. So again, the tangent of the angle is equal to the opposite leg, A, divided by the adjacent leg, B. Okay, so these would be the three trigonometric functions for angle A. Okay, now let's look at them for angle B. And the angle A is our blue angle, angle B is green. If you're following along with the lesson, this is slide 2 of the PDF for topic 8-2. Okay. So again, now opposite and adjacent, those are going to switch places because our perspective is different. Again, the vertices, think of them as your location. You're standing at the corner of this room. So if you are standing at point B now, well, which of the three walls is opposite, is across from where you're standing? Well, lowercase b. So from the point of view of vertex B, lowercase b is now the opposite side, the opposite leg. And again, hypotenuse is still a hypotenuse, no change there. But if lowercase b is now the opposite, well then lowercase a has become the adjacent side. So let's see how that affects our trigonometric ratios. Right, for angle B, okay, sine is still going to be opposite divided by hypotenuse. But from the perspective of B, opposite is lowercase b. divided by the hypotenuse, C. The cosine of B is therefore A divided by C. Since lowercase a, side A, is adjacent with respect to angle B, and the hypotenuse is still C. Cosine is adjacent divided by hypotenuse, so the cosine of B, A divided by C. And finally, the tangent of B is lowercase b divided by lowercase a. Again, angle B, there's the opposite, so then that's your numerator. And with respect to B, the adjacent is A, lowercase a. So, a few tricks to help you remember this. Remember, if you notice, the sine of A is the same as the cosine of B. And this will come into play later at the end of the section. Okay. And likewise, the sine of B is equal to the cosine of A. So if you know one, you can easily solve for the other. Now, as far as the tangents go, remember they're reciprocals. See, the tangent of A is lowercase a divided by lowercase b. But if we flip that around, we get the tangent of B. Okay. So another way to remember these ratios, these trigonometric functions, we have the acronym SOHCAHTOA. And the acronym stands for each of the words used in your ratios. So we break it up into thirds. So, ka, and then toa. So again, so, S-O-H. Sine is equal to opposite divided by hypotenuse. Ka, cosine, is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. So again, a little trick to help you remember these. All right, so now let's put this into practice. We're going to be moving on to page 3 of the notes, and we'll take a look at example 1. So example 1. So page 3, example 1. Page 3, example 1 uses the same vertices, A, B, and C. And we have 7, 24, and 25. So we're going to identify the 6 trigonometric ratios, for the 2 acute angles. Again, we're only dealing with the acute angle, sine, cosine, and tangent. We're not really dealing with our right angle whatsoever. So one at a time. Sine of A. Well, sine is opposite divided by hypotenuse. So let's identify the hypotenuse first. Here's my 90-degree angle. Across from it is the 25. So that must be the hypotenuse. HYP for hypotenuse. And again, as far as opposite and adjacent, well, that changes depending on which angle you're looking at, so it doesn't hurt to leave those alone. Well, since we're solving for sine, we already know that that's opposite over hypotenuse, so the denominator will be 25. If we're standing at A, which of the two is across from where we're standing? Well, that's next to it, so 7. So the sine is 7 over 25. See, not so bad. And what about cosine? Well, we've just established that 7 is opposite from angle A. 25 is the hypotenuse, so 24 must be the adjacent. So the cosine of A must therefore be 24 divided by 25, since cosine is adjacent divided by hypotenuse. And then finally, tangent of A would be 7 over 24. Since 7 is opposite, 24 is adjacent. Opposite divided by adjacent, 7 over 24. Now these would be your final answers. The directions say find the 6 trigonometric ratios. Answer as simplified fractions. Well, 7 and 25 have nothing in common, so this is simplified. 24 and 25 have nothing in common, so that's simplified. 7 and 24, nothing in common, so that's simplified. So these would be our final solutions. Now the assignment asks you to express the answers as decimals as well. I believe rounded to the nearest hundredth. So we simply take 7 divided by 25, which gives us exactly 0.28. So that's already rounded to the nearest hundredth. 24 over 25 gives us exactly 0.96. And 7 over 24. That one gives us 0.2916 repeating. But rounding to the nearest hundredth is approximately 0.29. So now we have the answer as a simplified fraction and a decimal rounded to the nearest hundredth in all three cases. Okay. So now we're going to move on to slide 4, to page 4 of the presentation. And we'll solve example 2. Because this will be a case where we have to simplify. And I'll show you a couple ways that you can do it. And for number 4, we were given a triangle GH, or for page 4, question 2, we were given a triangle GHI with side lengths 21, 20, and 29. 21, 20, 29. And I just realized this one doesn't reduce because of the 29, so we're actually going to have to scrap that one and do example 3 instead. Oops. So example 3, you're given triangle ONM with side lengths 15, 20, and 25. There we go. That one's going to work. That one will definitely work. ONM 15, 20, 25. So two ways that we can answer this question. You can just work with the numbers that are given and reduce, after you set up the three, the ratios. So we'll do it for angle M over here. Once again, we already start with the hypotenuse, 25. First, it's across from the right angle. Second, it's the largest of the three numbers, so that's another way we can determine that this is the hypotenuse. All right, so from the perspective of angle M, the opposite side is going to be the 15. 15 is across from M. 20 is next to M. So opposite, adjacent. So yeah, first method. Sine of M, opposite over hypotenuse, 15 over 25. Well, 15 and 25 both have 5 in common. Dividing both by 5, we reduce this to 3/5. So 3/5 would be the sine of M as a simplified fraction. And then if we divide, we get exactly 0.6. So now we have the solution as a simplified fraction and a decimal to the nearest hundredth. Since it simplifies exactly to 0.6, if you feel like it, you can add a 0 at the end here, but you don't have to since the 0 is implied. All right, cosine of M. Well, 15 is the opposite, 20 is the adjacent, so 20 over 25, adjacent over hypotenuse. Once again, simplifying those, both divisible by 5. 4 over 5, which is equal to 0.8. And that leaves tangent of M, opposite 15 over adjacent 20. That reduces to 3 over 4, which is 0.75. Now if you notice in each case, the ratios were all divisible by 5. If you look at the three numbers, they are all divisible by 5. So you can jump ahead to the simplification by reducing them right off the bat. We got 15 divided by 5, 3, 20 divided by 5, 4, 25 divided by 5, 5. So see, M, opposite over hypotenuse, 3 over 5. We can skip ahead by simplifying from the start. And we just write the ratio, divide it using the calculator, and there you go. Okay, so that concludes the first part of the lesson, just the basic trigonometric ratios and how to set them up. The next part will be a much simpler lesson. We'll talk about trigonometric ratios to find the missing side.